Now the next question is, they are trying to fix the problem. The problem has arisen here because three processes are coming here and one process is going out, and again it is immediately entering back, right? And therefore before setting this a process arrived equal to 0, it is trying to increment the process arrived, and therefore that particular value is getting lost, right? And so they are trying to fix it, and various solutions they are proposing in four options. Let's see which one is going to work fine. Now they are saying that which of the following rectifies the problem in the implementation. First one is lines 6 to 10 are simply replaced with process arrived minus minus, which means they are saying that these lines 6 to 10, instead of using process left, right? So if process arrived is incremented whenever a process arrives, then we could decrement the process arrived as minus minus, which means whenever a process is leaving, they are saying that don't use anything else, just replace it with process arrived minus minus. That might work. But the problem with this is, understand this, assume that all the process has arrived and now process arrived has become 3, and therefore everyone cross this hurdle. The first one to cross out will try to make process arrived minus minus, which means initially its value is 3 and now it will make it as 2, right? And then it exits the barrier, and again if it tries to enter it, then what it will do is again it will increment it, and this value will be 3 now, right? And therefore it will see that this while loop is broken, and again it will enter it. Therefore second time the first process will enter the will cross the barrier, right, even without having all the other processes arriving, which means if I use only one variable, the problem is, see, initially all the processes have arrived, therefore its value is 3, and the first process it left the while loop, and so it decremented the process arrived, which means it made it 2, and immediately tried to enter the barrier, and again it made it as 3 because increment is 3 now. Now again the while loop will get broken because now the process arrived is equal to 3. Therefore it will again enter the or it will again try to leave the barrier without other processes even entering it, right? So what is the problem with this? The problem is simple. A process is not at all waiting for other processes because of this simple change, right? So again this problem is all this solution is also having the problem. What is the problem? The process will not wait for the others. It will immediately enter the it will enter the barrier and leave it without letting other process join. That process, the solution is definitely not the one. And the next solution is saying that at the beginning of the barrier, the first process to enter the barrier waits until process arrived becomes 0 before proceeding to execute P of S. So that is what the problem is, right? The entire problem has arisen because the first process to enter the barrier is trying to enter it even before process arrived has become 0. So always remember that first process, whenever it tries to enter it, by that time process arrived should be 0. Then only it should come and make it as 1, so that the other process will come and make it as 3. Then everything can enter simultaneously. The entire problem has arisen because a process is entering the barrier even before process arrived has become 0, right? So what is the problem with that? How can you solve it? You let the first process which is trying to enter the barrier wait at least till the time where process arrived will become 0. So once it becomes 0, then no problem, then it will enter and it will make it as 1, and anyway it is going to wait at the while loop till the other process join, right? And next time the two processes will come and completely process arrived will become 3, and everyone can jump the hurdle. Therefore before this line, one more line has to be written, one more while loop has to be written there. That while loop should check if this process arrived is not equal to 0. In case if process arrived is not equal to 0, it is supposed to wait. Just write a while loop here, while process arrived not equal to 0, wait there. So once the process arrived has is equal to 0, then you can come in, right? That is for the only first process, right? And from then on everything, but then that requires some more code. Anyway, you think about the code that has to be written there. But anyway, the solution is, if the first process is allowed only after process arrived has become 0, then the entire problem can be solved. Therefore B is a solution, correct solution. Let's see what happens with the other solution mentioned. Now other one saying that context switch is disabled at the beginning of the barrier and re-enabled at the end. So it means that any process which is trying to enter here is going to disable the interrupts, right? Which means it will not let anyone enter the barrier till the end, till this point. That is dangerous, isn't it? What happens if the first process enters it? Then process arrived will be 1, from 0 initially it will be 0, and then it will be made 1, and then it will go and struck here, right? It will be struck here for process arrived to become 3, but then it cannot let any other process come there because it has disabled the context switching. Therefore, that only one process will get struck here and it will never ever leave the barrier, and so no other process can enter and change the value, so it will be in a struck there. So whenever that process is there, it will hold the CPU without giving the chance to any other process, and it will always be struck there, right? It is dangerous. So this solution is obviously not correct, because one process will go there and it will fall in infinite loop and it will wait there and it will not give any chance to others because it has disabled the interrupts, right? It has disabled the context switching, so it cannot come out. It cannot come out and it will not let anyone come in, so it will be stuck there. Next one is the variable process left is made private instead of shared. So how can we make this private at all? So here variable process left cannot be made private. It is like this. If you made it private, then we are not writing it on the board, on the wall. So what is the solution? I told you that any process who is trying to jump the wall is going to write it on the wall that I have jumped, so that the last one will know if all the process have jumped the wall. If you don't write it on the wall and if you keep it in your pocket, the number, the solution will fail, right? So public variable is required here. Private variable cannot work here. Why? Everyone need to access that variable and keep on decrementing it, right? Then only we can understand when all the process have left, isn't it? Without that, we don't know when to reset the values, right? So everyone has to access that common variable, therefore it has to be public, and whenever it becomes 3, we have to reset the values. So this is also not right. Only solution is this. But the problem is, how are you going to write the code in such a way that only the first process is going to check it, right? You just see it. That could be written in some manner, but anyway we are not concerned about it, so this is the option. Okay.